Okay, I'll get you started on this one. This is, we're on the same page. Solid formed by joining two hemispheres to the ends of the right circular cylinder. So cross section of this might look like this. Okay, so you put the circular, you've got hemispheres on each end, and then you have this cylinder. I've got it turned on its side, so this is three-dimensional. And we've got some numbers in here. Let's see. Let's get these. That's the radius in there. And let's see what else we have. Okay. Total volume is 14 cubic centimeters. And the radius of the cylinder produces the minimum surface area. Okay. Well, we don't know how long this is. I guess we would call it L for length. In fact, let's just go with X. It's from here to here. Okay, that's X. And this in here, it's R, the radius of the hemisphere. And we're trying to, okay, total volume is 14. So let's look at the volume of this object. The volume is basically two hemispheres makes a sphere. So we need the volume of that sphere, which is 4/3 pi r cubed. That's the volume of the sphere, or the two hemispheres. Now the volume of the circular cylinder, so we're going to add that, would be the base of the cylinder, which is pi r squared, times the height of the cylinder, which I was calling x. So let's turn on its side. So here's our formula. Now we need something. We're trying to produce minimum surface area. So this is actually a secondary. Okay, this is a secondary that we have here. Primary involves surface area. So surface area now. We've got the surface area of the sphere, which is 4 pi r squared. That's a formula for the surface area of a sphere of radius r. And then you have the surface area of this cylinder, which is the circumference times the x. So circumference is 2 pi r times that x. so this is our primary. Problem is it's got r and x in it. So what you have to do, I would suggest getting rid of the x. So there's a couple ways we could do that. I don't want to be too tricky. You can solve this quantity here for x. You could solve this quantity for, well, you know what? Yeah, I don't want to put an extra r in there. VR. Yeah, that might get messy, but you can solve this for x. So, and then substitute that in here. Or you could fix this term so that it looks like this term here. In other words, divide out one of these r's and put an extra 2 in there. So, but that's messy. The point is, we have two formulas here, and you're going to have to solve this one for x. Substitute that quantity in over here for this x. Then you'll be ready to find your derivative of s and get the critical numbers and find that minimum surface area. This problem is a little messy, but it can be done. Okay, you just got to stick with it, hang in there, and go all the way with it. So, by the way, you would eventually throw in that 14 for your volume V. So this is a constant in here. You can leave it as a V or change it to a 14, I guess. Let me just do that. I'm going to 14 minus the 4/3 pi r cubed divided by pi r squared. That's x. Okay, so we can fix that a little bit. 3 times 14 is 42 minus 4 pi r cubed over 3 pi r squared. So that's x. And if you put all that into this function, you'll get s is 4 pi r squared plus 2 pi r times this 42 minus 4 pi r cubed over 3 pi r squared. Okay, so you got this is a little bit of work here, but again, not impossible to do. So I'm going to leave it at that, and I won't take away all of your fun on this one.